Hello and thank you for listening my poster presentation on the reliability assessment of Bangladesh power system using segmentation method. The authors of this paper are Mohammed Karam Moni Rabi, Nahid Al-Masood, Mafruha Ahmed, Pratiti Paya and Mamoon Rabbani from Department of Electrical and Electronic Engineering, Bangladesh University of Engineering and Technology, Bangladesh. Introduction. Let's start with the core issue. In any modern power grid, a big challenge is uncertainty, specifically, the unexpected outages of power plants, known as their forced outage rate or FOR. This uncertainty directly challenges the system's security and reliability. For consumers, this unreliability isn't just an inconvenience, it can and should influence the price they pay for electricity. If some areas have a higher probability of losing power, shouldn't that be reflected in their costs? That's where our research comes in. Our main objective was to evaluate the reliability of the Bangladesh power system, or BPS, by calculating a key metric called the loss of load probability, LOLP. Simply put, LOLP tells us the probability that the available power generation will be insufficient to meet the demand. To do this efficiently, we used a powerful and computationally fast technique called the segmentation method, and we applied it to real system data from the last 6 years, from 2007 to 2012. Analytical technique. Now, you might be wondering, what is the segmentation method? Imagine we need to combine the uncertainty of all 86 generators with the varying daily load. Doing this directly is very complex. So, we break the total system capacity into small, manageable blocks, or segments. The process, which we call a modified convolution, works in 6 key steps. First, we model the daily load demand as a probability distribution. We then divide the entire power system capacity into segments based on the highest common factor of all generator capacities. We place our load probability distribution into these segments. Here's the core step, we then air-convolve each generator, one by one. For each generator, we create 2 scenarios. One where the generator is available, which we factor in by multiplying its availability. And one where it is unavailable, which we factor in by shifting the load distribution and multiplying by its forced outage rate. We then add these 2 scenarios together to get a new, updated probability distribution. We repeat this process for every single generator in the system. Finally, after convolving all units, the probability in the very last segment, representing the point where demand exceeds the total available capacity, gives us our loss of load probability, or LOLP. This flowchart on the poster illustrates this process visually. Results. So, what did we find for the Bangladesh power system? We calculated the LOLP for each year from 2007 to 2012. Our results are summarized in this table and graph. The key takeaway is this: a lower LOLP is better, as it indicates a more reliable system. As you can see, the LOLP was already concerningly high in 2007 at approximately 5.62%. You can track the fluctuations in this graph. For instance, when new generators were added in 2009, the LOLP saw a slight improvement. However, by 2012, the LOLP had risen to approximately 5.97%, the highest in our study period. This trend clearly shows that the rapid growth in demand from industrialization and urbanization is outpacing the expansion of generation capacity, pushing the system towards greater instability. Conclusion. In conclusion, our assessment reveals a poor reliability scenario for the Bangladesh power system, with a consistently high and rising loss of load probability. This isn't just an engineering statistic. A less reliable system leads to more frequent blackouts, higher maintenance costs, and significant economic losses for the country. The solution? Our analysis strongly suggests that to improve reliability, a focused effort on increasing generation capacity and reducing systemic losses is critically needed. This work not only helps quantify the service quality for utilities and consumers but also provides a crucial tool for future planning, including the integration of renewable energy sources. The development of reliability assessment of Bangladesh power system using segmentation method is an ongoing process, and we welcome any suggestions or insights. If you have any questions regarding this work or are interested in collaborating on future research in this area, please feel free to contact the authors via the provided email addresses. Thank you for your attention and interest.